In this question here, we're being asked to do some actions on the data that's been gathered here, and we're told here in the question that we need to remove any anomalous results to calculate the mean value for the speed of sound from the experiment that's been carried out here, and the answer that we're looking for is to 1 decimal place. So the first thing that we need to do is to look at the results and to decide if any of these are anomalous. Well, let's have a look at the time intervals. We've got 3.0, 2.8, 2.7, 5.9, 3.1, 3.0, and it should be fairly easy to see that all of those are reasonably close. There's a good degree of similarity apart from that one there, the 5.9. Well, it's around twice the size of the others, so therefore what we're going to do is to eliminate that first result there. So let's just make a note of this. So we're going to remove from any calculations the 5.9 second reading. Okay, what we're now going to do is to process the other results. So we've got the other 5 readings which we're going to use, and we need to find the mean of those 5 values. So what's happening there is that we need to add those up. So if we add 3.0, 2.8, 2.7, 3.1 and 3.0, then that gives us a total of 14.6. And we need to divide that by the number of readings. Now, of course, we now only have 5 readings that we're using because we've eliminated this one here. So we divide that by 5, and that will give you the mean value for the time interval, and that comes out at 2.92 seconds. So that's the mean value for the time. We now need to work out the speed of sound, and the relationship that we're going to use is speed equals distance divided by time. So let's substitute the values into this. Now we need to be a little bit careful with this because having read the details of the experiment, what's happening here is that the sound is travelling from the students to the wall and back again, and it's really important to allow for that. So we can see the distance from the students to the wall is 480 meters, but what's happening is that the sound is travelling to the wall and echoing back again, and the students are measuring the time between the sound having been made, travelled to the wall, and then heard back there again. So our distance is twice 480, so that's 960 meters. The time interval, we're going to use our value for the mean time, and that's 2.92 seconds. So what we can now do is to divide that, and the answer comes to, and remember that we've been told that it's to 1 decimal place. If you work that out, that now comes to 328.8, and of course we're measuring speed because this distance is in meters and the time interval is in seconds. Therefore the speed is going to be in meters per second, and we need to make sure that we've included that. So in that case, let's insert our answer here. So our answer is 328.8 meters per second.